Good morning, students. I hope you all good and be safe at home. Okay. Let us see the Unit 5 mechanical properties. Okay. In these units, there are five major topics are there. One is tensile strength, plastic deformation, strengthening method, fracture, and hardness test. The first foremost topic we call as a tensile strength. What is a tensile strength? It is nothing but it is a resistance offered by the materials when to the breaking, okay, to the breaking of that material when you applied some external force. That is we call as a tensile strength. It is nothing but it is a resistance offered by the material to the breaking under the application of stress or tension or some other some other load. Okay. And the second, the tensile strength depends upon the materials. Okay, some materials has a very high tensile strength, some materials has very low tensile strength. That and all we are going to see under the topics what are tensile strengths and what are the important properties and what is behind the basic theory behind the tensile strength. That and all we are going to see under the topic tensile strength. Okay, the second one is a plastic deformation. We all know that plastic deformation, what is plastic deformation, and it is nothing but it is a permanent deformation. Okay, that is a uh, when you applied a load to certain materials to a certain limit, the materials get deformed permanently. That is we called as a plastic deformations. And what are the how the plastic deformation occurs and what is the material how the material behaves inside it. That and all we are going to see the in the topic plastic deformation. The next topic is strengthening method, and this topic is nothing but how to strengthen the materials. Okay, there are different methods to strengthen the materials. The well-known method we all know that work hardening or stain hardening. And that we all know that in the SWOT, the making of SWOT, that and all comes under these topics only. Okay. The next topic is fracture. The very important properties of a material is what a fracture. Sometimes we call it as a failure of that material. Okay. Failure, fracture is nothing but it is a separation of a material, okay, into two or more parts. Okay, how does this fractures occurs and what is the basic theory behind this fracture? That and all we are going to see in these topics. The last topic is we call as a hardness test, and how hard is the material and how can we test this hardness of the materials, and what are the different measure instrument to measure these hardness tests. That and all comes under these topics. Today we are going to see only about the fractures. Okay, it's a very important, since it is a very important topic, I took these topics. Okay, fracture. There are different types of fractures out there. Oh, namely what is the brittle fracture, ductile fracture, fatigue fracture, and creep fractures. We are going to detailedly discussing about all these fractures. Okay. And what is mean by fracture? First you have to know what is mean by fracture. Fracture is nothing but it is a separation of a specimen into two or more parts by an applied stress. That we all know that one. Okay. When you apply a tensile strength or some stress to the material, it may break into pieces. Okay, that is we call as fractures, or sometimes we call it as a failure of that materials. Okay, fracture takes place in two stages. Initial formation of cracks. How this fractures occurs? It does not suddenly break up into two or three pieces. Initially, it forms some cracks inside the material, and these cracks will spread out throughout the material and finally get departure from, that is, finally it breaks into pieces. Okay, mainly the fracture takes place in two stages. One is in formation of crack and another is spreading of cracks. Depend upon the type of materials, the applied load, state of stress, and the temperature, materials have different types of fractures of that. That is, we all know that what are the different types of fracture mean: brittle fracture, ductile fracture, creep, and fatigue fractures are there. Okay. Yeah, this fracture is always undesirable to engineering application, because when you're working on some service missions or some missions or some other services, when the material gets fractured, it makes it undesirable to us. Okay, we all know that one. Okay, how does these fractures occurs? First, we all know. Usually, this fractures occurs due to the crack formation. Initially, the cracks will be there. How this cracks formed means, it may be formed during the manufacture, okay, or during the solidification of that metal or that materials. Okay, now, flaws such as surface cracks lower the stress of the brittle fractures, where the line defects are responsible for initiating the ductile fracture. Okay, we all know that what is the surface cracks. Okay, and what is the line defects? That is, we have been studying in the last semesters. Uh, Imperfection in crystals. Line defects is nothing but, you all know that a plane of lines, atoms are missing. If it is missing, we call it as a line defect. Inside the crystal, if a line of atoms is missed, we call it as a line defects. In such materials, there will be ductile fractions will occur. If their material has a crack on the at the surface, we occurs brittle fractures. Okay, and these are the different types of fractures. If you could look at here, this pictures, this is a cup cone fractures. How this cup cone is formed here, and here it is a what, a fibrous fractures. Fibrous, you can see it is a fibers out there, and it is a star fracture. If you look at here, it can get star fracture, and this is a granular fracture. The granular fracture is mainly we call as a brittle fracture. Okay, now let us see the detail about the brittle fracture. Brittle fracture is the failure. Okay, we all know that it is a failure with a minimum plastic deformation. That is, it get broken. It will be broken before the elastic limit itself. Okay, we all know what is mean by elastic limit. What is mean by elastic limit? Elastic limit is nothing but, it is a maximum stress applied to the material, uh, such that the material will regain its original shape or size. We all know that one. What is the elastic limit is? Okay, this material, this brittle fractions occurs within the elastic limits. That means it doesn't goes for the plastic deformation. Before itself it break down out. Okay, such a fraction we called it as a brittle fraction or failure, brittle failures. Okay, if you look at here, the brittle fractures increases with increases in strain rate. That means if you applied more strain to the materials, brittle fractures will occur. And the second thing is decrease in temperature. If you decrease the temperature, we get a brittle fractures. We all know that one. If you decrease the temperature, the material become brittle. Okay, when you lower the temperature of the material by quenching into a liquid hydrogen or liquid heliums, so that the material gets what, cool downs. If the temperature is lowered, the material becomes brittle. Brittle means it can be easily breakable. Okay, and the next one is stress concentration condition produced by the notch. Notch means is nothing but a crack end. Notch is nothing but it's a crack end, and later on we can going to see it down. Okay, the next one, what are the silent features of this brittle fractures? Okay, usually let us consider a material. Okay, let us consider a material. Let us consider this is a material. Okay, let us consider this is a material. Okay, in this material there is a atoms will be there. Okay, atoms will be there in a regular and periodic way. Okay, let us say this is inside the materials. These lines are denoting the uh, uh, planes. Okay, atomic planes. In each planes there will be atoms will be there. Okay, when I apply a tensile strength this to these what materials, tensile strength means if I applied load on both the sides, so that I am going to pull on either side of these materials, some initially there will be some crack or some void space inside the materials. Okay, if you look at here, this is a void space. Okay, when I apply stress sigma, this is sigma is nothing but a stress. When I apply to the stress, what happens? This crack will start to grow. Okay, uh, and this tip is we called as notch. This is tip we called as notch. Okay, the crack tip. Okay, when I apply stress, what happens? This crack will start to grow, and it goes throughout the materials. Okay, so that the atomic planes will be cleavage will occur. The atomic cleavage will cleavage means you all know that separation. Okay, separate, and finally the material will breaks. Okay, and this is the main how this brittle fractures will occur. We all know that. Okay, the next thing is this mechanism can be easily explained by the Griffith theory. Okay, this brittle fracture mechanism can be explained by Griffith theory. Griffith said that that is Griffith postulated that brittle materials there are always the presence of micro cracks inside the material, and this micro cracks will develop throughout the materials, and finally it breaks. Okay, this is the Griffith has gave this theory, and he said that when you applied it, that is let us consider again, let us consider material. Okay, uh, let us be, this is the micro cracks. Okay, this is the micro cracks inside these materials. I'm going to apply tensile strengths on both the sides. Okay, tensile stress means I'm just pulling stress on both the sides. Therefore stress will be developed at the crack also. Okay, that is a surface energy is created at these materials. Okay, and the surface energy will try to break this crack, or will try to develop these cracks. Okay, that is it will cleavage here at first. Initially a cleavage will occur at this tip here. While the cleavage occurs here, it releases elastic energy. Okay, elastic energies, and these elastic energies is now responsible for the further growth of this crack. Okay, these elastic energies will gives some energy to grow the crack further. Therefore this elastic energy will supplies to grow the cracks, and the cracks will develop throughout the materials, and finally it breaks. This is the statement given by the Griffith. That is, if you look at here, the statement is now you can explain, you can able to see the statement here. Yeah, the statement is given here. Okay, yeah, if you look at here the statement, uh, Griffith states that when the elastic energy is released by extending, sorry, yeah, extending a crack equal to the surface energy required for the crack extension, then the crack will grow. Okay, this is the statement given by Griffith. Very important statement. uh, this is the statement. By using these statements he can able to derive what is the stress which is developed at the tip of the crack, that is given by the formulas here. And this derivation is I already explained in a detailed explanation is given in your notes. You just go through the notes, that the derivation will be there. And this is the stress given by stress developed at the tip of the cracks when you applied what tensile strengths. Okay, and this is the formula. Okay, you just go through it, these formulas. Okay. Yeah, if you look at these formulas, okay, just through the look at the formula. Tensile strength that is stress is equal to 2 times the gamma. What does it mean by gamma? Gamma is the true surface energy, and E is the Young's modulus. E is called as Young's modulus, and where E is called half of the crack length. Initially, how much the length is the crack, and E is called in our notes. I given this E as a. Okay, just look at that here. Instead of E, I put it A. Okay, just go through the notes. Okay, you can understand what is sigma and what is and all. Okay. Uh, just go through the derivations. Okay, what I have given in the notes. Okay. uh, the next one is, yeah, that's all. Okay. Yeah, these are the brittle fractures. Now can you understand what is brittle fractures and how these cracks are formed? What is a brittle fracture? Brittle fracture is nothing but it is a failure of a materials without a plastic deformation. Okay, it is a failure of material without plastic deformation will occurs. Okay, that is very important. That means the failure of the material occurs within the elastic limit of that material. That is we call as brittle fracture. Okay, and the brittle fracture is cleanly explained by the what theory we call as a Griffith theory. Okay, Griffith theory, what is it states? The statement is given here. Okay, we just go through it, and he finally derived what is the stress developed at the tip of the crack. Okay, for a brittle fracture, say he derived it, and you go through the derivations which is given in notes. Okay, the next one topic is we called as a ductile fractures, the exact opposite to the water brittle fracture. Ductile fracture is nothing but is defined as a fracture or failure which takes place in a slow propagation of a crack. There the crack will propagate very rapidly. In brittle fracture, the crack will propagate very rapidly, whereas here the crack will propagate very slowly, and it shows some plastic deformation. That means it does not go it does not break before the elastic limit. It break, that is the fractures occurs only after the elastic limit here. Okay, this is the main difference between the brittle fracture and the ductile fracture. Okay, here the necking will occurs. Very important is what is it? The necking will occurs. Okay, if you look at here, here the specimen begins necking. You all know that if you take a wire, when you put it when you apply stress to that wires, what happens at the middle, the wire will get necked up. Okay, necking will occurs. Necking means you all know that neck மாதிரி அப்படியே கழுத்து மாதிரி அப்படியே சுருங்கி போகும். ஓகேங்களா, here the necking will occurs at the neck. A plastic deformation will forms, and some cracks at the neck will develop, and finally the wire get breaks down. Okay, a wire or material will break down. If you look at here, finally the cracks grows out over the surface of the specimen in the direction of 45 degree. Okay, so that only we are getting necking. 45 degree means, if you look at here, this is we call necking. Okay, uh, I can draw it here. Okay, this is necking here. If you look at it, this angle, this is a tensile strength. What is it? This angle means, what is the angle here means 45 degree. Exactly, it will be a 45 degree. Okay. Now look at here, you can understand what is it. This is a specimen. Okay, and if I apply tensile strength, start of necking will form here. Okay, if you look at here, what is it? The angle here, it is exactly what is 45 degree. Okay, and here it is what is here now happens. it's a crack at the necking will occurs, okay, and the cracks develops throughout the materials, and finally the end of the necking will occurs and it break down, okay, and finally it's breakdown. Yeah, if you look at here, this is a considered specimen, okay. When the elastic limit exceeds, the material begins to work harden, okay. Working harden means it goes for the plastic deformation, okay. These are the some of the properties of ductile fractures. What I have stated here, they are given here. I just go through it. Uh, and the next one is, this is a differentiate between what a ductile fracture and a brittle fracture. Just go through it here. Listen here. The material fractures, plastic deformation, slow propagation. In ductile, it goes what? Plastic deformation. In brittle, it doesn't go for the plastic deformation. Okay. Surface will be dull and fibrous. If you look at that material which goes ductile fracture, the surface of that material will be dull and fibrous. Whereas the material which goes brittle fractures, the surface will be shining and crystalline appearance. It occurs when a material is in plastic condition. Yeah, ductile fractures always occurs in plastic condition only. Okay, you all know that one. It occurs in the material in elastic condition. Yeah, because before the elastic limit itself, brittle fracture will occurs. Okay, after the elastic limit, the material goes for the plastic condition. Okay, you all know that one. It is a characteristic season of formation of cup and cone. Yeah, when necking will occurs means it forms what? Cup and cone. Here, no such a formation will occurs here. The tendency of ductile fracture is increased by dislocation and other defects in metals. Yeah, dislocations and will be occurs here. The tendency of a brittle is increased, decreasing the temperature, as already we are seeing. Okay. In ductile fractions, reduction in cross sectional reduction, that is, there will be reduce in the cross sectional area in what is a ductile fracture, but there is no reduce in the water cross sectional area in brittle fractures. Okay, you all know that one, because a necking occurs means there is a reduce in the water cross sectional area. Okay, that's all. These are the two types we have explained it detailedly: ductile fracture and water brittle fracture. And the another two types is fatigue and another one is creep one. Fatigue fracture is nothing but, we all know fatigue. Fatigue means, what does it mean? I think, hope you all fatigue about this COVID-19 because they keep on telling that more news is okay. Uh, the similarly, fatigue means if you do it repeatedly, okay, the materials get fatigue. Okay, some machineries, example, in two wheelers, the engines, the piston will repeatedly moving up and downs. Okay, therefore it may fatigue you at some other point. Okay, some other points. Okay, and that point the fracture may occur. That type of fracture we call it as a fatigue fracture. Okay, the fatigue fracture either may be a brittle fracture or a ductile fractures, depending upon that materials. Okay, fatigue fracture is nothing but when a materials undergoes a cycle of process. Cycle of process means either reversible or irreversible. Okay, cycle of sorry, irreversible process only. When it is goes for a cycle of process, the material get fatigue and fractures will occur there. Okay. Then the last one is a creep fracture. The creep fractures occurs when the material is subjected to very high temperature. When it is subjected to very high temperatures, the materials may get fractured or may failures. Okay, there is that means inside the materials the atoms doesn't will start to move, will start to vibrate very rigorously, so that it gets what get easily break down. Okay, creep fracture is nothing but when the temperature is high, the fractures will occur. Okay, that's all. These are the what different types of fractures we have seen. Okay, so I hope you understand what are the fractures. The main thing is here is brittle fracture and ductile fracture. Okay, brittle fracture is nothing but uh, it's a failure of materials without plastic deformation, whereas brittle ductile fracture is a failure of material with the plastic deformations. Okay, these are the main difference. Okay, between this, I hope you understand well, and you just go through the what Griffith theory. Okay, the derivation I derived in the notes I given to you all. Okay, I hope you all get the notes. Okay, you just go through that derivations. It's a very important questions. Okay, definitely I am expecting one 16-mark questions from this fracture in this for this exam, online history examinations. Okay, go for the just go through these detailedly. Okay, thank you.